we're going to be looking at quadratic graphs. And there's three different forms that you can be given a quadratic equation in. And it's important to have a comfort level with each of those three different forms. Each one requires that you know a couple different basic pieces of information. And each one we can get the same for values. We can get the vertex, the axis of symmetry, the x-intercept, and the y-intercept. Some of them are given to us in vertex form, which is what we're going to look at here. Now, it's called vertex form because you are given the vertex in this quadratic equation. If you look at the actual general equation here, you see that you've got this minus h and this plus k. And that's actually where our vertex is going to come from. Basically, if we're looking at a problem, I've got one here, y equals negative the quantity of x plus 3 squared plus 4. We're going to use that 3 and that 4 to give us our vertex. And basically what we're going to do is we're going to take the opposite number of whatever is inside the parentheses. That's going to be our x-coordinate for the vertex. And we're going to take the same number that's outside of our parentheses that we're either adding or subtracting. So in this case, the vertex is going to be negative 3, 4. So always the opposite number of whatever's inside the parentheses, that's our x-coordinate. The same number as what is outside the parentheses that we're adding or subtracting, that's our y-coordinate. Now once you have the vertex, negative 3, 4, it's very easy to get the axis of symmetry. All you're doing is you're taking that x-coordinate and we're going to use that to give us that vertical line. The axis of symmetry is going to be a vertical line that goes through the vertex. And in this case, x equals negative 3. Now, the x-intercept and the y-intercept take a little bit more work. To find the x-intercept, we're going to solve it using the square root method. And so basically what we're going to do is we're going to set y equal to 0 to find the x-intercept. And if we want to find the y-intercept, we set x equal to 0. So basically you're setting the other coordinate equal to 0, and that's where it's going to cross those axes. So for the x-intercept, I replace y with 0. And the reason I do that is I'm going to go ahead and plug that in to see where, when y is 0, where does it cross the x-axis. Now, I'm going to go ahead and solve this. I'm going to move over the 4. I need to isolate this parenthesis that we're squaring, so I'm going to divide both sides by negative 1. So I get 4 equals the quantity x plus 3 squared. Now, from here, I'm going to use the square root method. I've got something being squared on one side of my equation, and I've got a value on the other side. I can get rid of that square by just taking the square root of both sides. Now, whenever you add a square root into a problem, you have to use a plus or minus. So, I have not just 2, but plus or minus 2 equals x plus 3. That plus or minus is incredibly important in order to do that. Now, from here, I'm going to go ahead and move over my 3. So, I'm going to get x equals negative 3 plus or minus 2. As my x-intercepts. Now, these are the values for the x-intercepts. It's important that you go ahead and finish that up and go ahead and see, okay, we're going to write these as a point. So, negative 3 plus 2, that's going to be negative 1. Negative 3 minus 2, it's going to be negative 5. And I'm going to go ahead and write those as points. And that's going to be my x-intercepts. Now for my y-intercepts, this one's a little bit easier. All you have to do is set x equal to 0. So basically here I've got y equals negative 0 plus 3 squared plus 4. So if I go ahead and evaluate this, get the negative 9 plus 4. Then I'm going to go ahead and that's the same as negative 5. And from there, I've got my y-intercept. I'm going to write it as a point. 0, negative 5. And that is my y-intercept. So again here I got my vertex is negative 3, 4. My axis of symmetry, written as a line, important there, x equals negative 3. I solved using the square root method, ended up getting my x-intercepts of negative 1 and negative 5. And then I solved for my y-intercepts and got it at 0, negative 5. Important note here, you can have multiple x-intercepts. You're only going to have one y-intercept. These are all functions, so that vertical line test has to be in play. You only can have one y-intercept. We can have multiple x-intercepts potentially as we're doing this.